Yes. Because I request change the date.
Yeah, that's not an issue. That's not an issue. You can just sign here because according to certificate, I will just follow this date only. Because your next replacement will be on the 30th, right?
Yeah. Thank you.
Because if preparing the certificate, you want me to put the date over there. 31st, first, one by one, like that. Then after that, the next one will be 30th. It won't look nice.
Okay.
Yeah. True, right?
Okay.
Yeah. So I'll just put one shot.
Yeah.
Yeah. Will be easier for me.
Sure.
Then on the 14th one, that one will be on the 30th that you sign. Yeah. Okay.
Your laptop can work? The software? Actually, I no. But I asked them to give me this PLC file. Not same, the file.
What same?
PLC file.
Okay.
Not same, right? The format
Should be same, but
PLC file.
PLC file. Not same.
Yeah. The PLC file, the file is extension is not XC, no, not XC, MDC, no.
PC file.
Yeah. The old model PLC file.
Yeah. The extension is .pc file.
.SC. I mean the software.
That's all you right now.
This one. I miss off what's that?
Stop and start again.
Move to stop and start.
It's you stop and start.
PLC file.
Oh, it's PLC.
Yeah, they got copy me few folder lah, but I see cannot open also. No same. This RSLogix.
Oh.
This one is the machine operating file.
Mm.
This one can open lah. This one like control and different.
Yeah.
But that one is this one cannot. It's a PLC file. Is it? So PLC file is using what software?
RSLogix 5.
RSLogix file.
Version 500, right? It's RSLogix 5.
Oh.
Mm.
But the new one not cover the all everything. No.
No. The studio.
I thought this 500 can cover.
No, different. So that one is RSLogix 5.
Mm.
That one is different. Then 500. This 500 is only for these models.
SLC5.
SLC5 and MicroLogix. Then the RSLogix 5000.
Can cover.
No. It's different. It's the control logics and the compact logics. So now we have only Studio 5000. The Studio 5000 is just for control and compact logics. So you can use this model still need to use this. That's why this one they release the latest version. RSLogix 500 Pro.
But
Version 12, this is the latest version.
RSLogix 5 is very old version already, right? It's
Very
a-
old version, but it's exactly same like this.
Same.
Yeah,
Oh,
exactly same. You can
but why cannot open?
because the software is different.
So the interface only not same.
Yeah, interface everything same. The programming wise everything is same.
Have you found download online? Have RSLogix 5.
Yeah, I check.
Now you still got customer or training using
No,
Logic 5.
this 500 also no. I think after 5 years, I think after 5 years I bring one. That's why the most of the parts I don't have. I only have digital input, digital output, that's all. Yes. But I don't think so it can support Windows 10.
Oh, no.
You can download from their website. So their website have
Hmm?
the software.
Yeah.
But I think but no lesson.
Or
But I don't know the lesson.
they can emulate or crack.
No, I don't. I use
RSLogix 5. But software. Oh, discontinue already. Is it?
Yeah.
It's only the factory already
Discontinue the software everything.
Legacy.
Okay, so for later, I plan to do this one. For analog programming line, I think we can use the control logics using the RSLogix 5000 software.
Okay.
Because the RSLogix 5000 and this one also is same. Only for some functions is not here. Okay, so we can understand how the analog works, how to do the conversion and everything. Okay. Okay. So go back to PLC. Create a new project.
Yeah.
It is number 503. Yeah, this one.
This one.
No, 3. Yes. Okay, make it big. Okay, go to window. Arrange. Because this 5021, I mean this model don't have floating point. Don't have float value. Right. Okay. Alright. Then you go to IO configuration. Yeah. No problem. See the password. Read IO. Okay.
Alright.
Correct. Now what I want to do, go to channel configuration. Okay. So we are using channel 0, right? Okay. Channel 0, I want to change to lemon. You can put DF1. Okay. Then the bulk rate we can change actually 92. Yes. Okay. Then apply. Okay. Because the original setting is 1200. 1200 will become slow. Can change to 90. Okay. Right. Then that day we already covered. Which one we covered? Okay. Because from your previous project, I know lah which one we covered already. You save first this. Go back. Go to your folder. Yes. You put the date for. Sorry, date. Yeah, L1. Yeah. Okay, go to file, open. Go to your folder. Okay, date 3L1. Okay, open date 3L1. Go to that. Oh, nothing is it? Okay, nothing. Okay, then. Really, day 3 today, right? Oh, sorry, day 2, day 2.
Oh.
Go to open. Yeah. Day 2 project 3. Lesson project 3, project 2. Okay, go to project 3 so we can know which one. Oh, timer, max counter. Okay. So, yes, we already covered I think all this. Timer, let's unlock. Counter, max. So today we will deal with the move and compare function. Open back the day 3 L1. input, compare function. Okay, now go to input here. Yeah. Open. Okay, so we add one input, right? Yeah. You make it bigger. Okay. So if we add an analog, we get the analog input. Okay. Then go to symbol. Let's say you add this one. Start. Start. Okay, enter. Okay, the next one stop. Because press start stop. Okay, maybe you can use the true. No, don't use. This is two. Okay, go to two. You put a sensor one. Okay. Sensor one. Now, okay, sensor one. Okay. First, and go to output. Output. Okay, one motor now. Okay. Okay. Plus. Now, you add one. So what I want to do when I start, okay, let's say one motor is running, then the sensor will count. Once I reach some value, I will on motor number 2 or off motor number 1 using a comparison. Okay. When we add first, we add the anomaly open. Start. Then the motor output motor. So you latch when you not latch the holding branch. Motor, normally open motor. Okay, then you add a stop button here. No, we click yes. Stop. Normally close stop. Next, what I want to do is I normally open. Sensor one. Okay, add a counter. Okay, counter is C. You just put C. Yes. Okay. You just put the name counter one. Okay. Reset. Okay. Let's say just put 20. Okay. Accumulator is the counting, right? Okay, you compile. Verify. Why is it got error? Oh, wrong. You see? Output missing. This one normally open. you normally, no, normally open. Yes. Okay. Now what I want to do, okay, let's see. This one below counter is after 20 it will give counter done, right? Okay, but I don't want to use after 20. Let's say I want to use at 5. Okay, so I need to do a comparison. Okay, you add here. Okay. Okay. Can you see compare? Okay. So you have equal, not equal, greater than, all that. So let's say equal. Source A is what? Source A is your counter value. Okay? Counter the preset. Okay. Click the counter here. Okay. Dot. No. So no. Counter dot. No, you type counter. Counter 1. No, counter 1 dot. No, DN is the done, right? So accumulator. Yes. No need. So it means the counter accumulated is the integer. Let's say I want to count with 5. Just put 5. Okay. Then you create one output, that is the bit. You add one output. Yes. So I want to use the bit binary. So just put B. Okay, binary 3.0. Okay. You add a name. Motor off. Motor off. Motor off. Okay. Verify. Okay. So it means when counter reach 5, right? Then when it's equal, means when the source A is equal to source B, then this memory will on. That is the compare function. So compare function normally you can use in analog programming, all like these values I want to compare a value. I think mostly your programs, mostly I think they use compare function.
Motor off. But the motor off is not using back the motor 1 output like flash and match. Right?
No. You can use that. You can use these two here.
Oh.
Normally those. If you're using latch here, then you can use unlatch. Motor 1 unlatch. But in that case means I use a binary, right? Then I use these two kind of here. Okay, this one can close. So we can delete that. Okay, save, download. Change to run mode. Yes. Now you just then the sensor will on.
Oh, that's what I was.
Okay, so that is the function of comparison. Okay, so when we use analog, it's the same. Okay, but just now at the 5 it's on, right? Right. Okay, after 5 it's of course I'm going to using equal. Okay, now. We don't have analog test. Now we go offline. Okay, you add here one more round. Add one more input. No, sorry. Take out this. Go to combat. Okay. Greater equal, yeah. Yes. Greater equal. Okay, we use the same counter 5 accumulator. Counter 1 dot ACC. Okay, enter. Then the soft B, let's say put 15, double 15. Okay. Then because why I can put 15 here? Because we need to understand the counter preset is an integer value. Integer, because we have data set like Boolean, right? So we have a Boolean. So what? We have an integer. Okay, integer is 16 bit, which is negative 32,768,32,767. Okay, so when we compare also, so why it can accept the 15? Because it's an integer. Okay, it is an integer format. Then we have a double integer, which is 32 bit, which is negative 2.1 billion the value. 32.1. But this PLC don't have what they have a double integer. They have double integer. Okay. but they don't have a float, right? The real or they call float. Okay, this one so 32 bit of data. This one is, this value is very big. 3.4 times 10 to the power of 38 this big is the number. Okay, but this model, this SLC model, don't have the float. Then you can go for other models, yes, they have the floating point numbers. Okay, so if you want to the source P, right, so the comparison, you can compare, of course cannot compare boolean, you can compare integers, double integers, real. So here to compare, okay, compare. So the source is, so this one you can compare integer double integer or real. Okay, here also you can put another data also, not necessarily must be number. Okay, it can be, let's say you have two counter. When the both counter reach the same value, you want to on something, you can use that also. Okay, then later on what we do, later on we use the control logics, then we can, no, not control logics, we use the compact logic. The compact logic, I have analog card. So we can use the analog card, I have a temperature sensor, we can connect the temperature sensor, the transmitter, then we can do some programming. Then, exactly same thing here. Only different between the RSLogix 500 and 5000. All these same. All these same. Only different is this part. Because for RSLogix 500 and SLC500 and the PLC 5, they have an address. Like input means I, output means O. Binary means it's a B, right? It's an integer means N. For Logic 5000, they don't have that. That's the only difference. But the same concept. For each address, right, you're giving a name, correct? How you give the name? You go into here and give the name, right? That concept is the same. Okay? So if it is integer or double integer, just put like number 50 or any number. So this one means it's an integer or double integer. If I want to put real, it becomes 15.0. Then this is considered a real. So must be the same data. Here let's say we're using integer, here also must be integer data. Okay? Or you can put another data also here also. Then you add go to timer counter. Reset. RES. Then you add a reset. The counter 1. Yes. Okay. Now you test this. Just on 5 times it will reset the sensor, because currently the sensor value is what, 11, right?
Not yet reset.
Not yet, because earlier program don't have reset button.
Oh.
Now we go to 15, can reset. reset and start back. Here, this number, you don't see this number, it's confusing.
Yeah.
Because this one is showing the 15. But we haven't do any program for this lah, right?
Yeah.
Yeah, because why? Because I mean the program, because the moment you reset, but the sensor is still on, but so because why it can come on? Because of the what they call the scanning, how the PLC scan. Okay, when we reach 15, it will reset. Reset means becomes 0 lah, right? Okay, then my PLC go back and my PLC go to the first line to scan again. When he scanned, he said he saw the sensor is still on, so it will count again. Okay? That's how it works. So we go offline. Okay. Now we go to go to view. Go to here. First, to see where is the watch table. Bring the mouse here. Bring the click. Just bring the mouse. Next. Oh, it's not a visual list. Because they don't have to watch. So now what you do? You go to integer. Yeah, double click. Okay, you only have one integer. Okay, go to properties. Element, you add around 20 lah first. Okay. 20 integers lah. So N0 to N19 lah. This one you add a name data. Data 1. Okay, and this one data. Okay. Same thing. Go to comparison. Yes. Anything. Can take anything. sometimes right, won't show the name here. Okay, it only show the address. Here it only show the first one, the name. So if you want to troubleshoot, but for troubleshooting, I think the most important is the address. The name is not very important. Okay. Right. Just add one output, one binary output. Yes. B, yes. No, cancel. B, no, don't B, just B now. Then you choose this binary. Yes. So, yes, enter. Okay. Then you can use this to cut off the motor. To up, right click here. You can just normally close. Oh, you add the VI here.
Director punya apa?
Yeah. Yeah. Oh, can don't need to pull. You can copy paste here. If you pull means then it will be yes. Okay. Can you verify? So just now the comparison is take the data from the counter. Okay. Now this one is take data from the some integer values. Okay, so this integer value from where I get? Normally from the analog program. Okay. Right. We can test in your laptop because your laptop got simulation, right? We can use your laptop for the analog programming. Okay. Download. Yes. Yeah, of course, because you see both are same value. So if you want to change value, you must go here because this one don't have watch table. You put the integers. This. Okay. Then you can key in here the value. Just put any values. And enter. Then here. Yeah. Let's say more than 10. You add more than 10. So this is how we get the values. Okay, but currently we are manually keying that, right? If no, normally it will be from the analog programming. So maybe from the first one is from the analog and this one is from the touchpad. Then this is your set point, this is analog. That's how it works. Okay. You save this. Okay. Because this controller because this is a very normal. The my 505 not working. You know it's whatever. My 505 is spoiled.
Oh.
Then the other day I tried to communicate, cannot communicate. I don't know. I know one company here they can repair this, the PCB box. So need to send them to them. Okay, now what we do? Use your laptop first. Alright. minus 2 you leave it on because you're using emulator, right? You leave it. Very nice. This also can be nice. Okay. Now, this one that day we check, right? The floating. Okay. Now you go to IO configuration. You add 7 slot. Okay, you click on the number 3. Then you go down, look for IF 1746 IF. Oh, sorry, NI4, yes. Sorry. NI4. No. Look for NI.
M4.
Yes. Okay. Just double. Okay, then another one go to NO4. This one is a fixed. You want a voltage or current line, okay? Just choose anything. Current also can, voltage also can. Okay, now you click here. Go to advanced configuration. Okay, so it's a 4 channel, 4 input board. Okay, okay. So your output also same. Okay, can you close? Now, so the input, the data will go to the input. Click here. Yes, you see. 3.0. The one, for the one, you must be in bit by bit, 16 bits. Okay? See here, this I1 is your first slot. Your first slot is a 16 input type, so it must be a bit by bit. Okay? I3, slot number 3 is your analog, so it is a integer, so it must be, if you want to give a name for, okay, let's say for this, right, okay, you must choose here the bit by bit, okay, 0, 1, 2, 3 until 50. Okay, so for this one I must choose here, give it a name. So let's say I can choose this. Okay, click here. Let's say you put AI channel 0. Okay. Then this one, some others like AI channel 1, channel 2, channel 3. Okay. Same goes for your output also. First, go to your output. Yes. You see, number 2 is your output. So it must be a bit by bit. Output number 4 is your analog, so it must be a channel. You can read like in, if you want to read in decimal, you can read in decimal. Okay. Okay. You can change to decimal. Yes. So it will show in decimal values here. But here, of course, it will show in decimal. But it's not decimal, correct? It must be in binary, 1, 0, so you can choose. So whenever you want to read the analog values or any values, you can use this to read. Okay? Okay? You can close this. Okay. First, we see how it works. So different PLC, different data, different values. See, we have so analog, you know, right? Analog is a range. range, so we can measure in voltage or ampere. So 0 to 10 volt, or negative 10 to positive 10 volt, or 1 to 5 volt, 2 to 10 volt, and so on. Okay. So, but most common one is this, right? Okay. So for ampere, they are 0 to 20 milliamp or 4 to 20 milliamp. Okay. Now, so how it works? So let's say we have a CPU. Okay. Then we have an analog input module, right? Okay. So normally these modules are they call AD. Okay. But not common in Adam Bradley, not common in Adam Bradley or Siemens. This one common in Japanese PLCs, Omron, Mitsubishi, Kiers, or that they call AD because it's a analog to digital converter. They call, okay. And this one go to a transmitter. Okay, then the transmitter can measure anything and depend on what type of transmitter that. Let's say it's a temperature transmitter, so it will measure the temperature, for example, 0 to 100 or negative 50 to 100. Okay. Then what is the function of the transmitter? Convert this into analog values, that is 4 to 20 milliamp or 0 to 10 volt, the common one. Okay. The function of the analog AI card is convert analog to digital. Okay. If you convert the analog to digital, so what is the value go to the PLC will be different. Okay. So in that case, different PLC, different values. Okay. Same goes for your analog input card here also. Okay. So your AI card, your Google is on, right? Okay, you go to your Google, you go to this, you put I746, sorry, 1746 and I4, okay, yes. The first one, yes. You go to manual, and I4 manual. This is the one. Okay, go here. Click here. Programming software calibration. Okay. Go down. Okay. So this one is 4 to 20 milliamp, is it? Okay. So 4 milliamp. Then when you go to this that module, okay. So okay, go down. Scroll down. No, scroll down. Scroll down. Okay, here. That is right. Just now, okay, when you put a slot, okay, it become this number. Okay. I is because input, E means the slot number, then data. So this is how we do the address, right? Just now. Okay, go down. Go down some more. Okay. Same thing as just now we see. Okay, go down. Go down. I want to show the value. Okay, here. Okay, so this one I will convert current voltage into 16 V. Okay, if it is 0 to 10 volt, right? It means you will get 0 to 32767. Okay, if it is 0 to 5 volt, then is 0 to 16,000. Then if it is milliamp and these numbers. So this one is very important. Why? Because then only we know how to convert this value to our temperature value. Okay, so let's say for example we use 420 million. For example, so 420 million is how much? So it's 32772 16384. This is the value, right? It means temperature is 0 to 100, and this is the analog value. So it's 32772 16384. So we have to do calculation. Y equal to mx. Because this one must use the plus C because it's here, right? Then only we can get the temperature value. Okay, this one manually need to do the calculation. Okay, you go to, you see if there's any instruction. Go down here. Go down. Oh, that's all, is it?
Yeah.
Programming example. Yes. Go down. Okay, it's a scaling. Okay, go down. Go down. Okay, just doing the less than, greater than. Okay, alarms. Okay. Yes. They do this calculation, right? Because they don't have a block for scaling. We've got SL function. Go down. Where is the SL function? Go. Go. No. Go down. Okay, go down some more. Okay, here. Okay, so you can use this your own calculation or this SCL function. Means it's an instruction, it's a block where you can key in the values, you can calculate for you. Okay? Later we will see this one. Because RSLogix 500 they don't have this. They have scaling, but it's not in ladder program. It's in the function block diagram. Okay, later we'll try this. Okay. So any question this one?
So I can understand the concept, but never do the calculation.
Yeah, of course, later we do the calculation. That's why I normally have this the max function first, then only I do this. Easier to understand. Okay. So, but this concept you understand, right? They need to convert to this.
Rest of
Yeah. Go for a break. And after the break, we come and do the want a coffee or
Yeah.
drink lah.
Feel sleepy to
Yeah.
yes, remind to stay to work.
Go with my
Huh?
go to Shanghai and
Yeah, the deliver.
deliver the one. What's his name?
Sneak.
Sri. Yeah, better. Sri. I was contact him.
Yeah, for me.
Manual senyum betul.
Yeah. Gue tak boleh dah. training வரவே சொல்றாங்க. நீ என்ன பண்ணல இது வந்து normal வெறும் basic PLC தான் டச் பண்ணாலும் இது யூஸ் பண்ண முடியாது. So I tried to connect the touch panel cannot work.
Why?
This one not working with the Weintek with the final because the bound rate is very small. And I say that later I will use the HRDCorp for analog program. The RSLogix does.
What's the solution?
No, you can use this one. You need to use HMIS PLC. But
SLC500.
Can, but for this model, cannot.
Which model?
For older models can.
The 500 in Shopee.
No, not that one. Need to check which models support.
See, the
old Prophase support.
Old Prophase support.
No, I think better to if you want to continue with this RSLogix training, 500.
New training வந்துச்சுன்னா ஒன்று வாங்கிடணும்.
No need HMI. You buy the micrologics. அது வந்து இதோட replacement தான் micrologics. That one can communicate with that one by there.
But even வந்து ஸ்பெசிஃபிக்காக SLC கேட்டோம்னா
Assistant that's for sama வேற என்ன கேட்டா control ல அதான் கேட்கணும். இதுமே தெரியல. வெறும் இன்புட் அவுட்புட் தான் இருக்கு. எல்லாம் ஓகே நான் அனலாக்லாம் வந்து நான் வந்து இது யூஸ் பண்றேன். 5000 ஓகே நான் சேவ் I mean the software
மைக்ரோலாஜிக்ஸ் எவ்வளோ?
Huh?
மைக்ரோலாஜிக்ஸ்
I think the second bit
But you went for another training.
yeah another training.
Market training, I just put out a page.
Now, what we do? Let's assume we have analog input that is 4 to 20 million. That is, so the range is in between this. Okay, the range is in between this. So when we get the analog input, I want to convert to this. Okay, we do one programming here, then later on we can test the same way of programming in the 5000. Okay, we can minimize this. Okay. What do? You create a new project, or you just save as. You can save, yeah, save first. Okay, you go to file, save as. Yeah. I mean, go test. This one, right? Yeah. Okay. Go to file. Save as. Yeah. Okay. I put D3 and lock. Go to IO configuration. IO configuration. Okay, we already add this, right? Okay, you can close. Okay, now we go to input. Input here. Okay, first one is the start. This one. The second one. Okay, we try to do a project together with this. Okay, so we add the start stop first, later on we do the project. Okay, you add a stop. Okay, now then already assigned. Go to input first. Okay, and go to analog. For analog, this one is you add here. You can see here also, okay. Because for analog we have to choose this, okay. For digital we have to choose the bits, okay. So this one you can put is AI channel 0, CH0, okay. Okay, can close. For output, yes, double click. For output, okay, you add here. Let's say we add a heater. Okay. So analog output later we see. Okay. Later we can close. Now what we do, you right click the ladder to rename. Okay, you name it name. Main program. Okay, you add another ladder. Right click, new. Okay, number 3. Okay, you add here the name analog. Okay. Okay. Then this one you can delete. You add one more round. Okay, you know we need to add the JSR, right? Yeah. You click here, you look for program control. Program control. Yes, okay. The JSR. Yeah, clearly. No, you haven't add. Okay. So the JSR, add the analog. Cannot see.
Sure.
Then
It's only numbers.
okay, you put U3. Yeah. Okay. I think it must be U2.3.
Oh, you don't. No dot.
Yeah, 2 column. Yeah.
No.
But now we can choose this. Okay, let's put U3. Okay. Cancel. Verify. Yeah, because normally cannot enter. Because need to set it. Okay, never mind. You close this. Okay, just save first. Okay. We double click here. You tap L. Cannot enter. Why cannot? Numbers can. Let's see here. Okay, you verified? Okay, now we go to the analog and we do the program. Open analog. Okay, first. First we create the over limit and this one. Okay, you add one rung. Okay, you add compare. Compare, use less than. Yes, clearly. So the source is your analog input, the AI channel 0. Okay, you choose that. Your AI channel 0, yes. Okay. Enter. Okay. The value is 3277. No, the source bit, yes. Okay. Enter. Then you add output. Okay. You add the binary B3. Let's put B. Okay, binary. Okay, the first one, yes. Okay, enter. Okay, you give it a name, symbol. Okay. This one is overflow. This one you put underflow. Oh, this one you use overflow, and this one you can put underflow or below the set point. Just put underflow. Okay. Then you add another one. Same comparison. This one is greater than. Yes. Click OK. Okay. You just click normal. Okay. Same. The AI channel 0. AI. No, not AI. Yeah. Okay. This one is 16384. right where I get this number.
Yeah.
Okay. Then this one same, one output. This one is another binary. Just put B. Okay, binary 1. See, this one is overflow. So this one is 30.0. This one 30.1. Okay. This one is the overflow underflow. Now do the calculation. What we need to do is, it's a long calculation. First, to get the M, okay? Because X is our analog, right? Y is our temperature, C is the offset. Okay. So to get the M is the Y next, right? So delta Y over delta X. So to get the delta Y is Y max minus, but there's so many ways of calculation. X max minus X, okay? Then so first we need to do the subtract, then only we can do the divide. Okay, then X is from here, then C is, to get the C is Y minimum minus M X minimum. Okay, so we have to do this calculation. Okay, then only we can get an accurate value. Okay, right. Now what we do, first we do this. So for
This
that,
one in
yes,
the manual they have this formula.
no,
Not sure.
no, but they have there's so many type manuals. I mean this formula is like the normal linear equation manual formula we can use. But there's many ways. Sometimes what they do, because since this one got this offset value, right? So that's why you need C lah. If no means I don't need. If let's say it's starting from 0 to 100, 0 to this one, right? And I don't need to do this calculation. Correct, right? Straight away this one. Because of course the maximum minus minimum 0 is this value. So this you can skip these two calculations. Sometimes I have seen some calculation, some programming and they do like this. X maximum minus X minimum and sorry, X value, X value is X maximum minus X minimum. X minimum, okay? You take this value, let's say data 1, right? And later this data 1 multiply Yx minus Y. So, okay. So let's say for example, let's say this one is half, right? Let's say we just talk about from 0 to 16,000. Okay? So let's say this is 16,384 minus 0. Let's say this is 8,000 plus 8,000 192. Yeah, 8192. So let's say from here I will get what? 50, right? 0.5. 50%, half, right? Half of 16,000 I will get 0.5. Then use the 0.5, multiply this. This one is 100 minus 0. So you will get 50. Also okay. But if you want to do this calculation, make sure there is no offset. It starts from 0. And this also can, then normal like this, what they do is they convert this X value into a percentage. Then multiply the value. Okay, that's very big.
Today our scientific calculator in the computer have. No, right? We still need to do a manual calculation.
Okay, you go to scientific calculator. Can get the values.
There's no direct.
No, okay. Click here. Scientific, yeah. But of course I need to do, I mean you make the equation, is it?
Yeah. We still do.
No.
Okay.
You still need to use this function.
Yeah.
Okay, I will tell you, actually there's many ways to do. I will tell you how. First we do this one. Then later on, actually I can skip all these. I just calculate manually what is the M, because the M value won't change one. It's a fixed value. Correct? Because you find this, the difference between this minus the difference between this, you will get the M. So M is the fixed value. So just get the M, multiply with S plus C. C also you can manually using your calculator. Calculate the value. So you just make it instead of using the big calculation, very simple, small calculation. I mean, you can do a simple calculation. But there is a thing. Let's say, for example, in the future. So initially the value is this. Let's say after like 1 year, 2 years, you see you won't get accurate value of this. Right? Of course, need to calibrate that. Calibrate them, you see the value will become 16,380. It's not going to 84. So if 80 means, of course, you won't get 100. It's 99 point something. So in that case, I cannot change this. Okay, we will do that on you. Do one, can you? You go up. Actually, I can see how they do. Let's see also. Add, multiply, divide, add. Okay. Go up. This is the calculation that they do. Go down. Okay, multiply. They multiply. 400 is what? 400 is what? You go up. Using standard plan. Okay. This one is below the range level. This one below, above. Okay, go down. Okay, this one degrading alarms. Okay, go down. This is the analog value. The analog address. Okay, the analog address multiply 400. Okay, they put the value into something. This one double divide. Okay. Okay, then they add source A 100 and 70. Good. They use different type of formula, not this way. The food. Okay. This one they use the SCL function. There's a function called SCL. You can use that function as well. Okay. This one you got. This one they do whatever. Using scale parameter SCP function. What? So many. You can use this method also. Okay, we try all the three. Then we know. Yeah.
This one is a 31208.
Yeah, this one is for what? This one is for, I think it's NI0, different model.
Oh, different model.
Yes.
So got one table.
Yeah, go up.
Go up.
Okay,
There's one that show me one table.
Yeah, This one is 0 to, this one is for the output lah. NO. So for output they use these numbers. You see 4 milliamp is 6242. 20 milliamp is 31, right? Go up, go to analog. This one is for the analog input, if not mistaken. Go up. Yeah, you see, input data. This one is, you see, for 20 milliamp is 32, 16. So always you need to follow the manual.
This one I think is very rare. I never saw this one. Minus 20 million to plus.
No, very rare. I also never see.
I only ever see this one and this one. This one is the most common.
This one is common.
Yeah, this one.
This one also got very rare.
Yeah, this one I never see.
This one
Got people use it.
I also never seen before. Then this one 0 to 10, yes. 0 to 5, 1 to 5 also got.
Sorry, this LSB is what?
No, okay. LSB means left significant bit. Okay? It shows why, because it's 32,000, right? Okay, 32,000. Okay. 32,000 means it's become more than one integer. Okay? It needs 2 integers. Correct? Okay? So it means it's a double integer. So it shows that when you go double integer, means it go to the left significant bit, LSB. So because if you see only for that 2 only you have, because the value is 32,000. Okay. Because if it is more, because what it shows 10 volt is equal to 32,767. If more than 10 volt, what happens? Of course, it will go more, right? So if it is go more, then I cannot use integer. I need to use double integer. So it become like 16 bit plus 16 bit. Okay? 16 bit, 16 bit. Okay. So it shows that the left significant bit, it shows 1, right? 1 means here got 16 bit, right? Here also 16 bit. Okay, so it shows total 32 bit. So, but it's only using one left significant bit, means only using this bit. So if what happen when you do some calculation sometime, can I erase this?
Yeah.
When we do some calculation, you know our integer is n, right? N. So n8, you go to your PLC.
7.
N7, okay. 7. N7 dot 0. Okay. The first one, right? Okay. So when we do some calculation, whatever, this one is means it's a 16 bit. Okay, 16 bit. When we do some calculation, sometimes the value occupy 2 integers. Means it means okay like this. Okay. When we use multiply, for example, multiply n7 0 multiply n7 1. And the value go to the n7 2, for example. It means it will occupy 2 and 3. But what they tell you here is we only use the 2, the left significant. That is the meaning of LSB. They only use the LSB for the value num 32,000.
So what will happen if, the input data when they go beyond, so the channel will be error, or they will show like stay on the number, or it will,
okay, that is it depends on how we do program.
But the hardware device won't have any.
It will show. That one you must use the status S bit. In the S bit they have this there's one. I think just now in the example also got just now.
Right.
No. You go down. Go to the programming examples. It's not what they use one SB. But that one you can get from the PLC as well. Okay, this one okay. This one all they create themselves. This one all they do themselves. Okay, go down. This one, is it? This one is a clear fault bit from the overflow. This one to clear. S5 is to clear. So sure you will get from the S5 something. It's the what? The error. Overflow error. This one all they do themselves. The alarms. It's an older manual, you see, 2004 manual. You see, actually good, you know what older manuals are, they have this type of what? Example, you know.
Now don't have already.
Now new one don't have. But the new one, they have example in the software itself.
Oh.
Software, you go to the help function, they will have the example.
Oh.
But you know what example? They don't show this. They
So
only show
different.
this. They won't show calculation example. They only show, okay, if you're using multiply, how to use the multiply. That examples they have. So you can keep actually good.
Better.
Yeah. You know what? It is better to have all the manuals, all the hardware you're using, right? The control net, all the manuals are to keep. Because they use all these. If any data you want to take, right, you can take from there also. So many calculation type they using.
Mean it will like auto reset.
Okay, you go up. No, this one what they do is go up. If we scale the value to 92, okay. This one is the bit lah, right? The what? If there's an error, right? Okay. If there is no error, if the values go above the overflow, it will unless the overflow. You this one. Okay, we do that one. You see one. Then you can understand. Then you can know which one. Actually, this one is a longer question. Actually, you can most of the thing we don't need actually, but we do one. Then we can see which one we can take out. Okay, you add. No. First, I want to use float because I can't use integer. You know why? If y divide x, right, 100 divide these values, right, I will get floating numbers. So that's why. Okay, go to float. You add some data. Okay, you add 100 elements. Okay. Then the first one. Okay, this one. First one is here. Okay, you add all these y max. Okay, enter. The next one is y minimum. Here. Need to add here. Okay, you close this one. Actually, you can add here. Go down. You can add. Go down. Under here. Enter symbol. Yeah. Okay. You click on the y min. Yeah. You add new record. Okay. F8. Just put D1. Okay, enter. Then you add new record. Okay, FA3. Okay, 3. Yeah. Okay, it's X max. X max, X min, DX. No, under. Never mind. Can. X min, okay. Then, yeah, add new. Yeah. DX. Okay, for now this one enough. Okay, close. First we do the max function. Go to the max function. Okay, here. Compute max. Okay. Actually you can use the CPT also. Okay, but no, later we do that. You use the subtract. Clearly. Because why? CPT, right, only support in some of the model. Like this model, right, don't support CPT. The one I have. That's why the one I have don't have it. You see. The CPT you can select. Okay. The source A, you put Y max, Y min, dy.
Max.
Y min, dy. Yes. Okay. Do the same thing below. Another line. Same subtract. Actually, you can copy paste also. Yes, yes. Then this one you put X max, yeah, minus X min, then dx. Okay, so we already get this data. Okay, we already get this data. Now we do divide. Okay, we add one more. Actually, the line, right? We click here, right click. You can insert here also. I need to go and search. Can bring. Yes. Make sure it's okay. Now this one is you double click here. Okay, when you double click, right, it comes like this, right? Okay, now you key in divide, div, and then. But the thing is, you need to know the coding. Yes. So the divide is the dy. Okay, divide dx. So the result is the m, right? So m, we haven't created the m. Never mind. You put the f, f8, the float, yeah. Enter. Automatically 86 lah, right? The last one. Okay, enter. The symbol you put m. M is the rate. Okay. So we already get the m. Now I need to find out this. Okay, because okay, good. What we do for this, I need to multiply this. Then only I can divide. Right? I cannot do this formula. If I want to do formula, I need to use the CPT. Okay, but before that, I create the C offset. Okay, go to float. you click here, you right click, yeah. Insert. I think you click here and insert. Yes. Okay. That one is under the max function. Now you will have a CPT. The destination is the offset. Okay. The expression. Okay. Here need to do the expression. Expression I need to do column. It won't show, you know. It won't show the what. It won't give you the suggestion. So the what the name must be correct. Okay. Minus open bracket M multiply X minimum. Okay, close bracket. Okay, now you verify. No, we verify all. Okay, so correct. Okay, now you already get C. Then this one also same. We can do multiply first, then addition, or we can use the CPT also. Okay. So we use the CPT now. Same. You add one more line. Okay, CPT. Alright. So same. Y is a new one. Okay. It's a new data. So you put F88. Yes. Okay. Enter. The name you put symbol, put temperature. Yes. Okay. Now the formula is M. No, you put open bracket first. Sorry. Open bracket M multiply. Our X is the analog, right? Just now we already created AI channel 0. AI underscore CH0. Okay, close bracket. Plus offset. Okay. Yes. Verify. Oh. Actually, eligibility is good, you know why? Because you see, PLC cannot. Other PLC I need to convert first. Things done. You test the scaling first. And after that you want to do any something programming. You save, then you download. Yes. Run mode. Yes. Fault. Why fault? because you know why for? Because no values in the divide or that. Okay. Because of that, but we are not sure. But you click here. Click here. Go to form. A minor error being said. What is the error? S5. S5 is what? Refer to S5 minor error. Where is it minor error? I think here. S32, S33. Okay, we go to main. S5, where is S5? It's not here. Okay, go to scan. Okay, not here also. Go to scan time. Not here. Mat. S. No, so not there. Overflow. Okay, I don't. Okay, not there. Go to channel 0, channel 1. I think channel 0, channel 1 shouldn't be a problem. Go to debug. S5. No. Go to L. Because here is S5 stroke 0. Then. Oh, because of that. Yeah, I know max. Because I know why. You know why? Because the divide. This divide, the value is 0, and that's why. I know that one is normal. Just want to check. S5. Just showing what is it. Go to STI. The man, this one. S5. No. Protection 8. Alright, go to you close first. What we do? You go to the input first. Okay. Go to channel, the input here. Of course, we give some value first lah. Here. You go to change to decimal. You give some value in between this number. Just double click. Put 5,000. And then okay. Now it close. Next, go to float. Okay. This number, the Y max, all these number we need to give the values. That's when we get the value. Okay. The Y max, yeah. Y max we put 100. Okay, this one is okay. So it's Y minimum. Y minimum is 0. Okay, you go to X max 6384.
So when we connected to device, they will auto collect the reading, right?
Yeah. No. This reading we need to give. The analog reading, of course, it's from the analog. Okay, here 3277. Enter. Okay. Double click. I think we have entered. Hey, this is X max, is it? This one? Oh, sorry. This one cannot key in value. Leave it 0. Put 0. Okay. This is 16384. Okay, then this one is the 327. Enter. Okay, close. Now all the values there, but it won't calculate lah because it's in for. Okay, you clear the for. Okay, go back to run. So now can get some value lah. Okay. So now our analog input value is 5,000. Okay. Then you see this one, the dy is 100. Okay, go down. The dx is 13107. Okay, go down. So the m is 0.076. Okay, then you get the offset is -25. Okay. Now the temperature is 13. Okay, because why? Because we put 5,000, right? So 5,000 is around here. So you will get 13 something. So if half of this, how much? If you get that, then only you can get the 16. 384 minus 3277 plus 3277. Now you go to the I value. So you key here. No, not that here. Because this is the analog, right? You key 9830 and you get 50%. Actually, it's supposed to be 9830.5. Then only you get exactly this number, 50. Okay, good. Okay, now, okay, you can close this. Okay, you go up. This one you understand, right? This one is, if it is less than this, okay, this one on. This one is if more than 16,000, this one on. Then this one, if I can use bit, or I can straight away put a output also like alarm. But normally they don't waste the output, because for each analog low and high you put output means now you need to put a lot of outputs. Instead of using this memory, they do they create alarm in the HMI or that. Okay, now actually you don't need to use this. The dy and the dx. Okay, go down. You can straight away use this. It's okay. Okay, but you need to manually calculate the dy and dx and give this number. Or let's say this one also you manually calculated. Means you manually used your phone calculator to calculate this one. All these three no need to use. Okay, you go down. What you need to do, you just do this true. I just show you. Can I use? Yeah. Because I see many type of programming to use. Sometimes you manually calculate. Okay. What do you do? They use CPT. This one is destination. Straight away the temperature. Only one calculation enough to do. The expression is mx plus c. So what you need to do? You need to manually calculate the m. Using your phone calculator, calculate the m. For example, how much? 0.00762. Okay. So that's it. Then the offset also same. Offset is how much? Negative 25. Okay. Now when we do here, so m plus x. So m I already get a number. So I put 0.00763 multiply my AI channel 0 plus negative 25. I just do this way. Just one calculation number. So your m, you manually calculated, you already get the m, your analog input, then plus the offset. You can get the temperature. No problem. But now, let's see, because the earlier graph is how? 8277 16384. This is your analog input. This is the temperature. Now, earlier is this number, so you will get accurate accurately 9830, right? It's not right. Okay. So 9830 you will get around 50 dB. Let's say over the time what happens, right? These numbers will change. Right? Okay, because left of course plus minus. Okay. Let's say this one change to 3279. Okay, and this one change to 16390. So what we need to do? So when this one change, of course this number will change. So I need to manually again calculate, need to go and put it here. If I do this way, what I do, I just go to the X minimum, Y minimum, I just update the value. I just update the value, then I can, so it can what? Actually offset normally we don't calculate offset. This one. Normally offset they manually calculate. Plus minus. So what they do, let's say when they measure is 50 degree, but actual temperature when they measure using the probe are at 51. What they do, they just play with the number here. Offset, normally that's why the HMI normally they will have a page for settings offset. Okay. So currently negative 25. So let's say, but when you measure is different, right? They change to negative 24 or negative 26 plus minus like here. Then you can get the value. So because this is called calibrate. So you can calibrate if the probe or you can calibrate here also. If the probe. You need to just play the number.
The software or the reader HMI, they can, okay, I mean after decimal C I saw there is a 5 figure. So it's a default 5 numbers after decimal, or we can adjust like to become 1 or 2?
That one is in the HMI, you can choose how many number you want to show. Okay.
You know what I'm asking?
Yeah,
49.99.
Yeah, you do 149.999. I mean 996.9.
Yeah.
Just need 49.9.
Behind 5 is too long, right?
Yeah. You can normally in the HMI you can choose how many decimal point you want to show. Okay, and you can round up also sometimes. But here I'm not sure this one got round up or not. Add subtract square root, again convert to PCB. This one convert to PCB. You go here. See, but only I left the to what you can do, advancement. This one is the long. Okay, go. This one go there. Go there. No. Go some. This one ASCII control. Okay, next. File register. File shift move logical. It's just not SCL, right? Now what you can do, let's say I want to change this number to 50. I don't want decimal point. Okay.
Or maybe, I mean, just remain 99 or 49.9 the behind the one.
That one is in the HMI we can choose. That one no problem. But if you want to round up, that one need to do in the program. In the HMI, you can choose how many decimal point you want to show. So because normally floating we call real number, but according to the PLC theory, all the PLC real, they have two types. One is real, another one is a long real. But Bradley don't use that. But the latest control logics, no, I think so. But see in Siemens, in Schneider, all they use So what is the difference? Of course, the number is very big. Just now the real number I put very big number, right? So the real means it can show up to 7 decimal points. Normal real. Long real can go up to 15 decimal points. That's the difference. Okay. But if you want to show in the HMI, it depends on you. How many decimal point you want to show. Let's say I want to show 1, you just choose. In the HMI, you can, that's the setting. How many decimal point you want to show. That one is in the HMI. But here, if you want to convert, here it will show like this only. This one, we cannot modify. How many decimal? Because I don't think so, the floating can modify. Okay. But if I want to convert to integer, can. What we do, go offline. You know when you online, then you become offline, right? It asks you to save. You know why? Because the asks you to save means if you save with the value, you see. Electrically like that. If you offline and save, okay, you just offline save. If you do online and you go offline, but only this RSLogix for 5,000 they don't use that. Okay, if you go online, offline, just offline only. It won't save. But if you do online save, it will save with the value. Okay. What you do? You go to integer. Double click. Okay, you add property. You add 100. Okay. Then the first one you put temperature. You put temperature space integer int. Okay. Equal. Now what I do? You add one rung. Use move function. Just now you use move function, not yet, right? Okay. Use move function. Clicking. Move means very simple. Move from the source to the destination. Means move one data from here to here. That's all. Okay? Now, the data I want to move from here is the F88, the temperature. 88. Press escape. Then you can choose it. Okay? Move to the N7, the temperature integer. Okay, 70, okay. 00, 70. Yeah. Okay. If you choose, okay, there's a two way when you want to key in here. One you can choose the name, one you choose the this one, the and all that. Okay. If you choose the name means follow the name. If you choose N means always show the next unused to me. If you put just now right, when you put F8, it becomes F89, right? Because F89 is unused. So you need to manually key in. Okay? Okay. You verify, save, then download. Can you see? Become 50. Okay, because N7 is an integer, right? So integer cannot keep decimal point numbers. Okay? Go offline. Okay. Now, what we do, we use another way. We go to the slide just now. Yeah. You go up.
This is the output.
Output. You go up for the input. Input calculation. Okay. Using SCL function. Put up. Using scale. Rate. Offset. Okay, we try this out. But I'm not sure this one got scale. Minimize. SCL. You add another one. New for put SCL. Okay, go to the main. Yeah, double click. Okay, you add another JSR. Now go to the SCL block. So before that, I want to add another input. Yeah. Another input, go to the decimal. No, main here. You give it a name for this. Okay. This one just now is a channel 0, right? You put AI channel 1. AI channel 1. AI. Okay. Now you add a run. You double click the run. SCL. Enter. Okay. Now offset. Okay, destination. This one are very you go to help. Instruction up. Where is SCL here? This one can go in all these processes. Okay, go down, go down, go down. Okay, go up. It doesn't show what is that. Go up, go up. And I want to see what is the rate here. Just to convert into a variable. Okay. Scale to value. Actually, you see, this is my calculation, right? You see, the equation used in calculating a reading. This is the y equal to mx plus c. This is the m is the y max minus y minimum divided x max x minimum. Offset is the y minimum minus x minimum multiplied. Same thing. Okay. Now I want to see the rate. This one here. Over 1000. Go down. Okay, the rate slope is positive negative. Enter divided by 1000. Okay, we program constant over values. This one you can manually do. Value must be between this source must be a word address. So it's a positive negative. Enter divided by 1000. Put the
not related.
It's something. Because it's in the rate is divided 1000. So, like our rate is like 0.00763, right? So we need to put 763. So if 763 divide, that is what 10,000 is it?
Yeah,
10,000. Yes. No. Oh, so it means I need to put 76 divide 10,000. Then only I will get 0.0. But this 76 I need to manually calculate. If I want to use this, I need to manually calculate. Okay? And the offset also I need to manually calculate. Okay, we do this and see we can get the correct number or not. Okay? Go to the program. Okay. The source is the AI channel 1. Okay. This one is you put 76. Okay, the offset you put -25. Okay, the destination is the new lah. Okay, you go back to the manual. You see, is it integer or float? Oh, it's an integer. Okay, so let's use integer. So N71 is a new one. Okay, enter. You put the symbol. You put temperature 2. Okay. Verify. Now we download this. Okay, go to run mode. What is it? I think we need to. Okay. You see? Now you get the value 0. Your analog input is currently what number? Your analog number now is 0, right? That's why your temperature is -25. Okay. So now for the analog number, you go to the input. You add the same number 9389. No, not that one. Here. Yes. 9830. Can get 50 dB.
So this one more easier, right?
But you need to manually calculate lah. But even though you don't want to do manual calculation, you want to do like automatic calculation, can also. You know what you need to do? You need to add 2 more calculation. Okay. So let's say for now, you see the rate and the offset we manually calculate and give here. Okay. If you don't want to do manual calculation, what we can do is, but we need to find this lah, of course. So we can use the CPT. Number 1 is CPT. Let's say the destination. Okay, the destination is to the M, right? Here is they call rate lah. Okay, like call it rate. The destination rate. Okay. The calculation, the expression must be 2 bracket. That is y max minus. We do this, then we can x max minus x minimum, then divide this one, divide 1000. Sorry, 10,000. No, not divide, multiply. Because if you do this, you will get this number. If you want to get 76 means you need to multiply 10,000. So the rate. Offset also same. CPT destination offset expression we need to do is y minimum minus R. Okay. Sorry, so many calculation. Can do this. You need to do this because for the offset I need the rate. So what you can do this thing, maybe you can put M, no problem. Then second calculation you just do multiply, that is the M multiply 10,000 is the rate lah. Then the rate you can use here. So to get the offset, CPT, the estimation, this one is the offset. So this is the offset I want to use here. So the expression is y minimum minus M. M is this one because I cannot use the rate. The rate is already multiplied by this. M multiply the X minimum. X minimum is how much? So instead of using these numbers, I can straight away put numbers as well. Okay, not necessarily address. I can straight away put numbers. Okay, let's say 100. If you don't want y minimum, no problem. Just put 100 divide this one how much? 16384 minus 3277. Of course, this one no need to do anything lah. Then y minimum how much? 0 minus M multiply X. So M X minimum is 3277. So all need to play with the calculation. The only thing is here need to do calculate manually. That's the problem.
Break now?
What's that?
We break now?
Okay, okay. You want to go for break? Okay, no problem. Busy right today?
No, for some job.
Yeah. Because you asked me to change the date
Yeah.
also. No. Because I think you can see my calendar.
Also full.
Full, I see until when you know. Until second week of August.
Wow.
But the sad thing is all one page. One page will give. But weekends you are not available, right?
Yeah.
Yeah, that's the thing. Because if you are available on weekends, then weekends also get done.
Bang, mungkin petang sikit bang, mungkin petang sikit saya datang. Cek capacity saya itulah yang tadi itu lah bang.
Who have it or laptop can leave here?
Yeah, can, no problem. But nobody will come. So that I'll be here.
Okay, see you later.
Okay.
mamak.
Yeah.
But I saw quite many food that come,
Yeah.
expensive, but got people still order delivery.
Yeah. Some more expensive.
Yeah. Weird, huh?
Yeah.
That day I having the nasi, 27 I include one drink. 27, 28.
Yeah, but these two famous for this one.
Famous, ah.
Famous for biryani.
Yeah, I saw, yeah, many food vendor come.
Biryani, one they famous. Actually, initially they opened lah, but
Many years already.
yeah, almost before COVID.
Or they can supply through the COVID. Many shop F&B closed during the COVID.
During COVID, because during COVID only one shop only.
Then you can supply.
And that time, below here they opened what? Car wash.
Oh, car wash.
Yeah.
Car wash came in? How did car can
Now coming, I mean before COVID lah they opened.
Hmm.
Car wash, below here car wash, then that one is open. Then during COVID of course like need to close down. Then after that, after open everything, then they come up with this restaurant. They are friends. That's why the same name. Vigna.
They're friend.
Friends. The
But
owner.
oh.
It's not. I thought same owner, but no. It's
Oh.
different owners. But they do a lot of this one lah. But a lot of business. Initially they opened the next this one right. The first floor initially is a property.
Oh.
Vigna property. Then only they come up with this restaurant.
It's a local people.
Yeah, local Indian.
Okay, yeah.
Yeah. Then only they open this. During COVID, they only do delivery only. They didn't close, they do delivery. But during COVID, I ordered one time, my balance is from
Here or you order from home?
from home.
Then you call Panda.
Yeah, during COVID lah. But they didn't cook here, they cook in their house.
Oh, during
Yeah,
COVID.
during COVID time. But that time, the taste is different really. And after open back, then the taste okay. But a lot of
Maybe the chef is different.
Yeah, chef, yeah. During COVID, a lot of not COVID, a lot of Singaporeans come here for makan.
Because like this kind of more premium cuisine India,
Yeah.
not much also right here. Not really many choice mah.
Actually, got.
A lot I thought
I think if you go to the Tampu area there, I think there
that one is the mamak Like
Mama is different.
yeah,
Mama is Indian Muslim.
yeah.
But here, I mean the Tampu area, I think the Indian cuisine are like this.
A lot.
A lot. I think 1, 2. That area itself, I think around 5 restaurants.
But all is a local people, local India trade.
Yeah, local.
Because all this mama I saw is a foreigner India
Yeah, foreign. Yeah. I mean the workers, yes, the foreigners.
Yeah.
The workers they use.
All the local is a foreigner India. You speak Malay or speak English, all they cannot understand.
Yeah. After
Oh.
some time only they can understand.
A bit only lah. Malay.
Hindu. Hindu is a majority. I think it's not.
You got like Muslim got focus in one area or actually the whole country also have little bit. You know what I'm asking?
Yeah,
For
yeah.
certain like maybe some state, like all is a Muslim or
No, don't have.
or they split
Actually,
like
mostly in Hindu. India, mostly Hindu. All the place they have little community lah, like Muslim communities. Yeah.
But when I talk to the foreign worker India in Singapore, they told me in India actually they got like hierarchy.
Yeah, of course.
So when they read their name, they already know their father ancestor is a high level or low level.
Yeah, the one is still.
So because that time I worked in one company in Singapore, quite many Indian from India.
Yes.
So we got like around maybe 30 or 40%. All is from India. Then some honestly some is a skin like not so dark, not
Yeah.
so they are more white a bit.
Yeah.
Yeah.
Because they are not.
Then they fight because we rent in one big house. Not okay. Some is a dormitory, different rent. So that time we have too many workers with 30. So the company they rent like one standalone property.
Okay.
So all live inside.
Okay.
Then they live together. So they eat, shower, everything. They like in one property already. Or they fight. They fight. Then until not until police lah. They fight. Not until fight very until but they push and
Yeah.
then after that intersect, we masuk campur, we go and interview, ask why.
Oh, I see, yeah.
Then slowly they tell us a lot lah. Got 2-3 person is a more higher level one.
Oh, yeah, this one. Okay.
Then he feel like he tak boleh lah, kena macam insult lah. I stay with your guys.
Yeah.
Then he will bully all these people. They ask them, when I eat, you cannot sit on the table.
Yeah. Still like India.
Then he use his shirt
Mm.
to wipe his shoe, wipe his car like that. Wow, then they fight off.
Oh.
Then he will scold him like low level. So he feel that he himself is like atas one.
Yeah.
Yeah, then he will scold the other. Then when I say, how you all know? You all in Singapore now is like,
You're a foreigner already.
yeah, they're all the same foreigner. But they say when they check the name, they can tell already.
Yeah.
Your kampong is where? Then they already know you living at like which kampong.
Yeah.
They already know you is low level.
Yeah, they already know from the name itself. Because still in India they use the names.
Yeah, then he said some temples some group of people can go in.
Yes.
Yeah, they got like different. This is the atas one. They could say, wow.
City now in India, cities all okay. But in rural places, kampung
Still like that.
Still like that. A lot of Indian movies also.
But now India was already no king already, man. Like why still got this kind of hierarchy? Last time got king.
Now it's like a president. But
Yeah, republic.
yeah,
Country already, man.
country, but still that. Even
Like still got ketua kampung like village.
people killing on this, there's a recent case because I normally Indian in Malaysia they used to watch
Yeah.
Indian movie from India all the news so I recently got one case that is the one lower caste they call caste lah, right?
Oh,
One
caste.
lower caste guy lah, he's a lower caste then his girlfriend is a upper class lah.
Oh,
Okay.
success lah like that.
Not success, upper class. So what happened? The family all know this. Then the family say, okay, cannot all this.
Yeah.
But the guy is he's working in a good company, It's
Big company, huh?
Big company. It's a big company in India. They call what? TCS. It's a IT company lah. So I think monthly India money they call 100,000, Indian money. I think Malaysian money I think more than around 10k like that. Then he went to, so he working in the city. He went to his kampung. So when he went to kampung, the girlfriend called, okay, you come and meet my
parents.
both the parents are police officer.
Oh.
So he went to his kampung. Then that time the guy's grandfather is not feeling well. He's in the hospital. When he come out from the hospital, the girl's brother come and pick him. He said, okay, come. My father call you. We want to talk to you. Something like that. But I'm not sure how true is that. He bring him alone. He used the parang cut, 47 cuts.
Why?
Because of his caste. He said how you can,
Touch my ladies, but
Yeah.
touch my girls. Boleh macam gitu?
yes, still there, in kampung.
Oh yo.
In kampung still there.
He-
Every year you can heard some news like this.
Wow. But how was the school education system? They still teach like that, man? No teaching about the class anymore, right?
School education is okay, but the guys lah, sometimes here in Malaysia like Indian like some is gangster, sometimes if you grow up in that community,
Actually, same lah.
but somehow there's a political things because the politician there they use this caste system to survive, to make something. Then from
Yeah.
there
Then he also get
they use that
business, power, all this.
Still same. But the education system, most of the place like education system is
But your guys have many language dialect difference, right?
yeah, in India, but I think it's more than, if not mistaken, more than 300.
Oh, speak. But writing,
Writing, I think,
only they got told me is a two type only. Hindu and Tamil is different, but they can read, understand a bit.
no, not. But because Hindu, but Tamil and Malayalam, Telugu, so many.
This one Google have don't have right? Google have because I always see it's a Hindu and Tamil only.
Yeah, Hindu is that's the main lah. Tamil is one of the community. Tamil. So they can read right out. Then there are some others also.
Wow.
I think in India they dialect because north side towards to China all they mix the China.
Already mix up.
Yeah, you can if you see
You can see the
also,
face different.
the face also different.
This already mixed already.
Yeah, already I mean because it's towards to the the
South.
the no towards the north is more to they are all white skin because it's near to the cold place. Near to the Algae or that right.
But they also mix with the China's people.
China people, their language is different. So many languages. Indian.
Okay,
But if you know English, you can survive in India. Even sometimes some place they don't know English also. Some rural place, the guys who live there they don't know English.
But my friend last time he got go India to okay, they also want to import Indian worker come Malaysia. So I don't know how he connect, then he go to find Indian agency and go there.
Yeah.
But what I say is actually one person go there, very risky also. He say he nearly gonna kill. Don't know what he did he go to accidentally meet some robbery or what
Yeah, what a lot of time. Another thing, there's a lot of cases from India. Some agents they go, okay, you because sometimes they say okay it's not studied well all that, okay you go to this company all that okay they say okay come I send you to Singapore, I send you to Malaysia, then they ask them to pay something.
Yes.
After that they scam, you know. A lot of scam. A lot of scam.
But now I think India is the biggest country export the labor right now.
Yeah.
China also reduced already. Back in 10 years ago, it's China, but now China people also reduce already, come out already. They all
Because they already built the place.
Yeah. Now it's the second is India now. India is come out
Now
already.
India is growing up.
Yeah,
But you see,
export all
if India and China cannot get along but if India and China get along nobody can touch.
But when you see actually India and China the religious is more close, you know.
Yeah.
It's more close because what we trust like Buddhism and we pray one is close with the India, you know.
Yeah.
The only got religious conflict and war is Muslim and Catholic.
Yeah.
They also actually is quite similar.
What's the middle?
Yeah, Jerusalem. So they always fight.
All normal.
Not that many Singapore got company come in they outsource like IT, security, this PLC also to India company also.
Yeah, India will be good. In this one IT or very smart. India. The day I had one guy from Singapore, it's a Chinese guy. He said his friend, his co-worker from India, they said they have a training center like this. They go and teach in universities. Then the guy from China, he's a Malaysian working in Singapore. He told me that, why not you do want to do that? I said, you cannot. For that, you need to have more equipments.
If you are Muslim here or Sunni here, you can do a lot of things.
Yeah, correct. Even you know what last time, there's one company, I think during my boss time, 2019 like that. Malays, two Malays, okay. Girls, okay. I think more than 40 plus. They come and do the training and everything. Then they say, why not you have these equipments all that. My boss said no. Because all this my boss invests. There's not one device, not one part also you get from the government. They say, straightforward, the Malay, they say, if you are a Malay, then you will get all of this.
That's right. They already got so many privilege. Now still everyday cakap like kena macam dia punya bumi kena. Anjam. Who Anjam? Who threatened them? All the things is on their hand.
Yeah.
But every day keep saying that we
Yeah.
are the threat, we are the crisis.
But
Oh,
it's-
siapa ni semua orang
All
politician.
because of politics.
Yeah,
You
they
see Kelantan, how the Kelantan?
create the rumors and
I
scare
think
people.
Kelantan is the second poorest in Malaysia. You see?
Kelantan. I pass by lah, Kota Baru, but not living there lah. Yeah,
Kelantan.
the city is not so developed.
Yeah. I think first one is the Sabah. The second poorest, even some in Kelantan, I know one because during my poly time I have my friends lah from Kelantan. Same guru doing project or anything. They tell me even some place in kampung they still have dirty water.
But they still every day want to promote their religions.
Yeah, they want to promote this politician, what they do is they want to keep them in that way.
Yeah.
So the guys will depend on the government. So to get all this one, all during the
So whatever
election
they, whatever they talk, then they will choose believe lah.
They don't want them to grow up, come out from the Kelantan. But a lot of Kelantan is working in Singapore.
Now, oh,
From Terengganu, Kelantan, they come out already. They already shifted to
better lah. Need to be educated. Then
Yes.
they start know what they.
Education is the only thing.
Yeah, to change them.
Yes. Indian also same, a lot of Indians. Okay, now what we do? So that's just now we see the others, right? Okay. Now what we do? No, like this, go to window, arrange, then I default. Okay. So just now we see this, right? Okay. There's another type also. We go to the here. Go down. This is a scale. Another one is this is a SCP. Okay, SCP function. That's the one. Minimum. You go offline. Okay. For that we add another another
Okay.
routine here. You put SCP. Okay. Then same in the main, you go to main. Yeah, open. You add another one. Put the SCP. You add open. Double click. You add one. You add SCP. You just double click. Yeah, double click there. You add SCP. Okay. Alright. So this one, you don't need to do any calculation by yourself. No need to find the n, no need to find the offset. Just key in everything here, you can calculate. Okay. So for that, you go to input. We use the channel 2. No, go to input. Three already. Okay. No, you do use this one. Okay. Put AI channel 2. Okay, so the input there, the input here, yeah, you add the AI channel 2. Okay, then the input minimum, how much? 3277. Let's key in 3277. Minimum 0. Yes. Scale max 600. Then output must be a n. Must be an integer. 72. Okay, 72 is not integer. Give it a name. Temperature 3, like for example. save, download. Okay, run more. Yes. Now go to input. Okay, go to decimal, choose decimal. Key in the decimal part, yeah. Key any number in between these, you will get the temperature. Yes.
So the unit of measurement is just displayed as a HMI or SCADA, right? It's not here, right? You get what I mean? So now you put temperature is either Celsius or Fahrenheit. It's
So
not-
the unit won't be here.
Nothing to do with the PLC, right?
Yes. But PLC just show the number only. So it depends on you whether to use Celsius or Fahrenheit or Kelvin. Then in the HMI only, in the HMI also it's just display. Then it's just
Dummy
a
one,
text
right?
only.
Just a text,
Just a text only. Yes.
So the other AI card all same also.
What's that?
Is this model got 8 channel
Yeah.
analog? Yeah. Yeah.
Channel, I think.
So all the script coding same, right?
Same thing.
It's just a more channel only.
It's a more channel and depend on like these numbers, right? These numbers is depend on whether you are using milliamp or voltage, because this number is for 4 to 20 milliamp.
Yeah. The table just come.
The table just now, yes. And for analog output is a different number.
So other model of the AB PLC, I mean, compact logic or control logic, also same or, I mean, the same I'm asking is these numbers 3277. I mean, these tables.
No,
It could be a difference.
different.
I'm asking this table.
Yes, I know the table just now, the number, yes.
Yeah.
This one different.
So control logic, compact logic may be different.
Different. This one is different. When you go to MicroLogix, MicroLogix is different. You know why? Because MicroLogix, they don't use this card. Because this card is only for the SLC500. So it's always, the concept is based on the card you're using. This one is similar to like Omron Mitsubishi. So it's based on the card. So what card you're using, so you need to go to the menu and check. Only Siemens is same. Only Siemens, whatever module is same. Only because they have, you just exclude the old one. Exclude the old one, the other type all got.
S7 almost all.
All the S7 is same. Only one model called SM200. Only that is different. The rest of the S7, they have 300, 400, 1005, 1002, ET200. All these the same now. That's why when you do that, you don't need to refer to the manual when you know lah. But you need to know this line, all same. But for other Bradley or other brands like Omron, Mitsubishi, must go to the manual and know.
I remember I ever saw Omron the reading they're using is not 32767. It's like 40,000. Yeah, 4,000. Yeah, 4,000.
But they have a lot. Because if you're using the small one, compact one is the 4,000.
Okay.
If you're using the modular one also, some is 12,000, some module is 16,000. 16. Not more than 32,000. Any model, not more than 32,000. Why? Because always must be in one integer. So one integer maximum 32,000. So must be in one integer. Cannot be two integers. So all same. Even later we will use the compact logic. Compact logic same. But the thing is, what is the good thing in the compact logic is they give you option. What type of value you want? Do you want in engineering unit? Do you want in percentage? Do you want in PID format? But the things, all these values you need to know. What is the values?
The biggest number mean the range could be a more details. The
Yes,
the
because
more
normally
decimal we
yes,
go.
That one will be in the number of 16 beacon bits lah, but this one it shows that normally they call resolution.
Yeah.
How many bits resolution? So if 12 bit means it's smooth. Then let's say you have 12 and sometimes because 12 bit, 14 bit, 16 bit. So 16 bit is more accurate because the resolution, because they have 16 bit of values. Okay, good. Okay. Now this is a analog input. Okay, we do one for analog
So
output.
why I don't understand. So this SCP mainly seems is more easier.
Yeah. You got three type of. One is you do your own calculation, right? Inside here we do our own calculation. Inside SCL we use the SCL block, but we need to key in the M and offset manually lah. Here the SCP is you key in everything here.
Yeah. So why they don't just simply using this
This one, I
SCP?
think because the older models don't have this SCP.
No, they don't have SCP.
Yes.
Oh. Okay.
Yes, this one the SCP is because of this. I think inside here you try to key in SCP. I'm not sure this one got or not. Because don't have routing. Yes, you go to SCL. SCL. Okay, this one is same because you know why? Because older model. I don't think so. In PLC 5 they have this. In PLC 5 they have the SCL. Yes. It was the same concept in the Siemens also. The older one is different. The newer one is more easier to do the programming.
Yeah, that's why after you explain, then why I need to do the first one so many calculation. Also need times because when have error, right, you also spend a lot of effort to find out where is the error.
Where is the error?
Yeah, if you using this one, easy, you can see where error.
Yes.
The very first method, wow, I need to check back where is the
error, what's the calculation error, everything. Same. Because that's how because the different of what? The CPU types. Different CPU types support different. Even this one, the analog we do, right? We have a function called the CPT.
config.
Yeah, this one, right, this one. In this model, don't have CPT. So, it depends on what you choose also lah. But nowadays, okay. Nowadays, any model, they have a CPT ready.
Okay.
Nowadays, the Studio 5000, any model you choose, you got the CPT. Nowadays, they don't focus on this. Nowadays, they will focus on what they call focus on IoT. So when you buy a PLCs, it depends on this PLC cannot support IoT, this PLC can support IoT. Now they focus on that. Then yesterday one guy called me, he's an IT guy, he want to build PLC because his machine using PLC. He want to build PLC and want to take this data to the cloud. He asked me whether I can teach or not. I say yes, I can teach, but currently I don't have the parts, the modules that support. Can use some third-party software as can support. Have you heard about OPC? You know, like OPC. Can use OPC now. OPC is I think it's the good choice to do IoT programming. Because OPC can take any data from any PLC. That's the good thing. Even this PLC can do directly to the cloud. So I use OPC. Take data from here to the OPC. From OPC, then I can share to anything.
But not all PLC got support OPC, right? All have it.
But it's not the
Maybe
OPC in the PLC.
It's a third-party platform software,
Yes,
but
yes.
what is the code? I mean, I don't really know the technical part.
Yeah. But it depends on whether the OPC have the driver of your PLC to take data. The most important is the driver.
Because I got saw some of the system, the SCADA, the PLC. So The machine itself got computer also, so got PLC also. So they use OPC to talk to this machine CPU. So they collect some reading or status
Yes.
through OPC open network, OA or UA. OPC UA.
Open and OA and UA.
But I'm not familiar lah. I understand it a bit. It's like network communication. They transmit.
Just need to take that. It's like a server.
Yeah.
They call OPC as a server. Just take from here and send to
Display only. But
yes.
they can do any like activation start stop through OPC. No right?
Through OPC cannot.
Yeah, they only display send the data here.
They just have
Display.
work as a like a server. I take data from here, I send to you.
Yeah.
I take data from here, I send to you. So must have two clients. Only one client, I can take data, I can only display only. Let's say, because if let's say you want to do like generate report, want to do like Excel. So you can just OPC enough. Take the data from the OPC, generate Excel sheet or generate SQL database. You can do that. But from there, you want to control now. If you want to control, you must have some other software.
Cannot control.
Yes, another maybe a HMI or touch panel or SCADA or that.
But the OPC can have one function like not to say control, but it can through like example, from far they can use OPC to come in my laptop, right? To control my laptop, right?
Yes.
Like they like team viewer or remote viewer, they can move, right? You know what I'm saying? Like example, these two laptop.
Okay.
If both got OPC driver, so these two laptop may be far away lah, from other countries, so I can open this desktop so I can control the computer. You know the team viewer?
A team viewer can.
Yeah, he said OPC also can serve a function like team viewer.
Oh, that one I'm not familiar. What?
No, other team viewer.
I know team viewer.
So when we give the other party on the access code, they also log
That one-
in team viewer,
yeah.
and they can come in my laptop.
Yeah, that one is normal lah. Because but there's still the software in your laptop. The other side they don't have the software, no problem. They just need a team viewer because that's what normally I do. Sometimes my participants sometimes they cannot communicate or sometimes.
Yeah.
So when I'm free, they call me and say, can you do team viewer? But nowadays I'm not using team viewer. I'm using AnyDesk.
Any desk.
So I say okay, you connect first, okay, let me make up for you. Then they will connect, but I make sure their laptop must have the software.
The team viewer also need a lot of high speed data connection because I
Yes.
sound very lag.
Lag.
They're very slow.
That's why we use AnyDesk.
Oh, any desk. Last time they also share me another platform called Show My PC.
Oh, okay.
Similar lah, I think similar to team
Oh,
viewer.
a lot.
A lot lah, but Show My PC when I use right, not so lagging ah. Wow, the team viewer
Team viewer.
if one party the connection speed slow then you like kind of move on very.
Yeah, team viewer is because team viewer, if not mistaken, they are own.
Yeah.
From last time they have. Nowadays, even last time I connect to one of the laptop from Mongolia, one of my participants. So that time he got some issue. Want to back up, so got some alarm or anything. Then he said, that time I was offline, I'm at home. Then he asked me whether I can connect or not. I said, okay, I can. Then I asked him to install AnyDesk. Then he said, Mongolia cannot install AnyDesk.
Yeah,
They don't have AnyDesk. They only have Ultra View. Then he sent me the installer. Then I install it in my laptop. Then I
But some on-site, our customer or some on-site industrial station, they don't allow install software. Unless if already have, when we open it's not administrator, we want to install software, then cannot, they control, restricted.
yes. That's why even sometimes, because this the software I give you like, cannot install in your company.
Oh.
Company laptop with no license, they will lock. Okay? Now we do for analog output. Okay? Analog output. Okay. We do the same thing here, then we can understand. Because the other two you understand right now. You only do is here. Okay? Okay, go to offline. Yes. Okay. Okay. You add. Okay. Before that, you go to output. You add one output here. Okay, the first one. Let's say AO channel 0. First, you add another rung. same, we use the SCP. Because SCP must be here lah, but I don't know where is it. Because whatever we choose here, right, sure we have inside here. Here is like a shortcut lah, okay. The output is your AO channel 0. Yes. Okay. Then the input is my set point. So you see here. Now this is an analog input, right? So I take the analog input, I convert it to a temperature. So normally this is called scaled value. So Y lah, right? Okay. What I do a probe. Because when you, this one, when you do troubleshooting, right, you can understand what is the value of it. Okay. This one for analog input. So for analog input, just now do this one is an AI channel like 1, 2, 3. Let's say we talk about the channel 2, okay? So they have 3, 2, 7, 7, 16, 3, 8, 4. Okay, why? Because this is a 0 to 100. This is the temperature. So this is the negative 25. But how we get this one need to calculate lah, right? So this is the offset. Okay, this is 4 milliamp. This is 20 milliamp. If it is a voltage 0 to 10 voltage, it's a different value, right? So this is the, and this is the axis, right? So this one they call is the input. Okay, this is the called, they call the scaled value. Okay, this axis lah, right? Okay, input and the scaled value. Okay. And sometimes they use this for temperature. They use as a engineering unit, because this is where the unit, right? Whether it's a temperature or pressure or something. For analog output, same thing. Here will be the analog output. Okay, channel 0. Here will be the set point. What is the set point? So here will be the engineering unit. Okay, then these numbers, okay, is based on what is the our output. Okay, go back to the slide. This is the analog input, right? Okay, go for analog output. No, you go up, go up. Go up some. Go up some more. There's a small table just now. I saw here. Go up, go up. Here. This is the okay, analog output. Okay. So let's say we talk about 420 milliamp, right? This is the number. So it's 6242. 6242 31208. So the data will be like this. Then our set point is depend like what is our set point. Let's say this depend on the analog output is controlling what. Let's say it's 0 to 100%. It's a percentage, example. So this is 4 milliamp. This is 20 milliamp. So this one is the offset. So in this case, you don't need to calculate the offset manually, because you know already what is the offset. In this case, because you need to calculate to get negative 25. Okay? Right. Okay, go back to the program. And the the same thing. This is called input. This is called the scale value. So the scale value and input it won't change, because input means is the x-axis, scale value is the y-axis. It won't change. Only the analog position is changed, because normally we know the x-axis is the one always change, right? The y-axis is follow the same thing here. So this one I get the value, I convert into a engineering unit. Now here is from the engineering unit I convert to the analog. Okay. So the input must be your own input. So you can put any n integer. Yeah. Just put n. No, on the integer here. Yes, n. Integer 73 is not using. Okay. Okay, you make it set point. Okay. Then input minimum 0, maximum 100. 6242. Maximum is 3120. Okay. Now we go to save, download. this. If you put 100, then you will get this. Yes, if you put 0, then you should get this. Yes, 624. Very straightforward. If they add this lah, if no means you need to do manual operation.
Omron got SCP.
They don't have SCP, they have SCL, but you can key all this data. Because this SCL is different. This SCL is just what they call, they just the manually, right? The M you need to key in manually. Like most of the PLC, most of the PLC is similar like this, but they call SCL lah. They don't, because this one is scale with parameters. So Omron, Mitsubishi, Siemens, all that. They have normally they only have this type of. I mean this one they don't have. Normally, this SCL block they don't have. They have mostly like this only. But in ControlLogix, we don't have. We don't have SCL or SCP. You need to do manually, or you must use the function block diagram. Because here I don't think so. This one got problem. You go offline. You right-click the program files because it's just go to properties. Number of files I'm using here. Okay, because you right-click new. Because you see, you cannot. Okay, allow online activities there, but you cannot, use different language. They only have ladder. Okay, we close. Okay, this one you save. Just save it.
So let's say if I want to use this output. Example, so this output integer n72. So I will use for trigger something. So I will put here. Is it?
Okay.
I will put here examples.
You want to trigger what?
Trigger output.
Trigger what? Digital output.
Yeah.
So you must use compare.
Using compare.
Must use comparison. You want to use this output value, right? The temperature value, right? You must use comparison.
Oh, not create a.
Normally open,
Ah.
cannot.
Oh.
Because normally open only can accept Boolean. So our I is a Boolean, O is a Boolean, and a B. So N is not Boolean. N is a 16 bit, means 16 Booleans. So I can understand.
Okay.
So because normally when we add value, of course you will add something like, okay, when I reach certain value, then only I want to count down. Right now. So must use comparison. Then must use comparison. Okay. Okay. Same thing here. But this one all you can do some programming lah. Below what you want to do what if you top over the flow. These two you can use for all the other programs as well. This two is not only for this. These two for other program also you can use the same thing. Sometimes I have seen some program like this. Okay, I show you. Go to SCP. how the programmer do. Okay, you click here. You right click insert run. Okay. Normally the programmer, the input, right, they don't directly put the input here. Unless it's just normal programming, of course, they just do. But if you want to do a proper program, like okay, if it is, let's say the value overshoot, what happens? If the value is below the value, what happens? Okay, because make sure, because it's don't don't damage your system, right? So they use a lot of move functions. Okay. Use the compare, use the less than, yeah. Okay. The source is the I32, yeah. The I32, the AI channel 2, right? Okay. Cannot be less than 3277. Okay. We create an output. We use the bit binary. Okay. So use a new bit. No. Just put B first. Delete that. Okay, B. Okay. Binary. Okay, 32 lah. Okay. Can. Okay. Because just now we already used 0, 1, 2. Okay. You add another round, insert round. Same thing like this, we use a compare greater than. Okay, same thing. AI channel 2 input 3 to run. Input 3. Okay. Cannot be more than 16384. Okay. Then you create another bit. Okay. This one 303. Binary 3. No, don't put B here. Just put B. Okay, binary 33. Yeah. The name you can put like over lah, it's over range lah, over range. Okay, this one you double click. I mean the BI change to below range. Okay. Now, you verify first. Error as no instruction.
Round 4.
Just double click here. Okay, okay, go up. Go. Okay. Okay, click here. Add one round. Okay, now over the range. Okay. You put normally open. Put normally open. Normally open. Yes. Okay. This one. Okay. You use the below range. Yes. Okay. Then I move. Use move function.
This one.
Yes. Move the AI channel. It's the same thing now. AI channel 2. Okay. The destination you put one new integer, the n. Okay. 74. Wait, here you put the same name, AI channel 2 value. Okay. 4 you use here, you put it here. You replace this. No, no, no. Not that. I mean this one delete.
Oh, this.
Yeah, delete, use the N7 form. Okay, alright. Compile, make the verify. Okay. You add more. Actually, you need to add some more. You add another run. You add another 3 runs. Okay. Now, here put normally open. This one is the above range. Okay. Below range. Okay.
Overage.
Oh, over range. Yeah. Over underscore. Okay. No, just now. Not this value. Sorry. You take out this, the source value. No, no, here. The source value you take out. Yeah. Erase. Because if it is below range, is on, I move 3277. 3277. Okay, that one is correct. Correct. Okay, copy this, move. Copy. Okay, you paste here. No, we need to right click this. Yeah. Paste. Move. No. Bring the mouse here. Bring the mouse. Okay. Now this one must be the 16384. Okay, so it means if it is, so this one, if it is below, if the analog input below 3277, this one will on. Okay, so if this one on, I move this number to here, the scaling. Okay, same thing, if it is over the 16,000, this memory will on, so I move 16,000 into the N7, because N7 is the one I am doing the scaling. Okay, I add another 2 run, go down, another 2 run. Okay, here is the same thing like this, but normally close. Okay, if it is below range, you put the below range. Yes. Okay, same move function. Okay, copy that also. Okay, copy also. Okay, copy one of these. Copy. Okay, then here you put the analog address, the input 3 2, right? Okay, okay, right. Now same thing, over range normally close. Then just copy paste. No, this one, copy paste this. Copy paste this one. Yeah. Copy. Yes. Okay, compile. I just verify. So this 4 is because I'm using the N, right? This one is what? Actually the AI channel 2 value. I use this one to do the conversion, right? But this value I get it from where? Okay? I get it from the analog input. I write, okay? Input 3, channel 2. Okay. Now, if this 2 memory is not on, whatever value in the analog, I just move it here. Same, whatever value in the analog, I just move it here. If it is above or over the range, I move the minimum and the maximum value. Okay? So So what happened? I just want to maintain this number. I don't want this one go to 0 or go above 100. Okay? You test this one, then you can understand better. Save download. Go to run mode. Then you open the analog. The input. I. No, okay. This one. No. You close this first. Go to the SCP. Yes, okay. Now you see, now the range is 9830, right? So these two memory is not on. Correct? Okay, go down. So means this one won't function. Okay, go down. Now these two can function, means whatever value inside the input, I just move to here. Move to the N7, integer 7, right? Okay, go down. Then the calculation based on whatever value inside here. If it is go below the range, okay, now go to the input. Where is the channel 2? Yeah, go to decimal. Okay, now this one you go below 33,200. 2,000, okay. So now you see it is below the range, right? It means below range, I move this way. Something is wrong. Go down. Go down some more. Oh, okay, over range. This one is happening. Because this one is overriding my value. Because I'm supposed to move, my plan is go up. My plan is this one. I want to move 3,200 into the N7. But now I'm moving the 2,000, right? Because of this go down. Because of this guy. It's moving 2,000. I need to interlock here. I need to copy paste this too. Okay, go offline. Yes. Okay, what do you do? This one you put it. I mean copy paste. No, you copy the normally close. You click on the normally close. Okay, copy. You click on here. Okay, paste. Yes. Same thing. The below range. Okay, the below range you put it here.
Drag.
No, copy paste. So if it is below or over, I can move this data. Okay? So this interlock means if it is over or below the range, I can move. If it is in between these two range, then only I can move this data to here. Okay? Now you verify and download. Now you see what is the value. Now you put some value. Now 2,000 is it? You put. You see, you put 1,500, right? But my N7 value is still 3,200. Go to the SCP and see. My temperature is 0 now. means I make sure my data is always from 0 to 100. If it is below this or above this. You put in between the range, in between the value. Like 5,000 or 8,000. So if it is 8,000, then I can move the 8,000. Okay, go down. Yes. You see the N7 value here. So it's a 36 degree. If I don't do this right, it's 2 right. It's for data, right? If I don't do that, what happens? If the value below here, then it becomes negative temperature. If value above this, and it becomes 100 above. Now you put some value above the 16,000. So the N7 value is still 16,000 only. So you see, I cannot move the 21,000 into here. Why? Because it's over range. Just now we put only one, right? So cannot. So you must put both. So in this case, actually you can modify some. Go up. In this two, no, this two. In this case, both this one same, right? So actually this one we can add a branch here. We can just put it in. Oh, actually, why? Actually, this run no need to do. Because you see this run and this run exactly same.
Yeah, I was trying to understand.
Yeah, so this run no need to do. Actually, you can go offline and do. Run number 5 only. Go up, but these two must have, because why? I'm moving different values. One is 3,200, one is 16,000. So I'm moving different data value. I need two. But this one just now is both same, so one enough. I have some program I've seen like this. They do like this. Means if it is overshoot, I want to make sure this one is don't, I mean the value, because you know why they do this way, because later on, go down. Later on they use this number to do some programming. Correct? Like temperature reach 100, I on something, off something, right? They do. So this program was actually not complicated. You go up. Not like complicated, you go up. What they do, they add additional, that is they use this number, these two memory, right, to control your program also, to cut off. If it is above, then it give alarm. It will tell you, okay, because if you see the moment I get below 4,000, means some problem. If I get 0 milliamp, it means the cable is broken. That's why normally they use the 4 to 20 milliamp. So this is how we can do program. Or sometimes it's just direct. They just use the direct SCP only. So now they don't do. So direct SCP show the value. So if the value is more than 100 already, then you know it's error or something. So because all the error you see in your HMI, the programmer need to create a program for it. Because the errors all, you know how it works. You go up. They need to create this. So they will use this bit 302 to on alarm. Same for this one. We use 303, they on alarm. Okay. Now what you do, I think you can use the same this one. What I want you to do, you go to the analog. Do we use any start stop model, right? No, right? No. In the SCL also same, I didn't use. Yeah. Okay, you go to the SAPE. Here is the, I already got the temperature, right? Okay. We use the temperature, go down. The temperature A, yeah. Yeah, we use this. Okay. What I want to do is, I want to do a simple control, just on off output using this temperature. Okay. Now, you can use another ladder. So the concept is very simple. I think we already just now we created on output heater, right? You go up. Heater is 0 heater. Because the same type of programming I do for the VTM project. I made it simple like this. Start. Okay, we have a start button. We have a stop button. So we have two buttons, right? Okay. But the two buttons we need to manually on like here. Because we don't have the push button, right? And this is the heater coil. Okay. And the heater is on. When I start the heater on, when the temperature increases. Increase. So the temperature increase, let's say the temperature. I want to maintain the temperature in between 50 to 60 degrees. So when I start, the temperature increase. So when it's more than 50, heater will cut off. Okay? When the heater cut off, okay, of course it will cool down. Go below 50, heater on back. So it's just off, on. Okay?
Understand, but right. Okay, step by step.
This is try first. Okay? So what you don't do here. Just go to program file, you add another one. This one you can put a heater control. Okay. Yes, this is where you do that. So the start stop very simple. Start, heater on, stop, heater off. Then I need to do two comparisons. One comparison is the greater. When it's greater than 60, cut off the heater. When it's below 50, on back the heater. Okay? one I'll check with my manager. Okay, okay. Okay, I'll check my manager and update you. Boleh. Okay.
think I lost already. I don't know how to do. Don't know what I'm doing also. Lost.
Okay. Okay.
I think it's wrong. I don't know how to do.
Okay. The first thing is
I think you can start to
no.
redo everything.
Let me no need to redo. We see. Go error at first. Okay. So the 7-2 correct, right?
Don't.
This one is the SP. Okay. 7-0. Go up.
No, I think. Yeah. But you want to show me how to do again?
Oh, okay. Oh, you do again this one. Is it?
Yeah.
No need. This one no need. This one you can take out.
Okay.
No need. No, you click here, just delete. Because why? Because you already created here.
Okay.
Okay, you go there. We already created this scaling. We already created this conversion. That is the 7-2, right? Yeah. So no need. We just use this. Go to heater. We just use this to compare. Yeah, this one is correct. Okay. Now the idea is okay. When I start heater on, when I stop heater off. Okay, it's correct. Now, when compare heater on, okay. Now this is if it is less than lah, right? So now I cannot on the heater 2 times. Okay, but I know that when the temperature, so when I want to start, I make sure the temperature is below 50. Right. So this one is correct, but the thing here, these two we need to modify. Okay, you change this to normal output. Just delete normal output. You use not heater. Not heater. Take out. No, you take out the O2. Okay. You use the binary. Use a binary. Okay. Yeah. You undo. No. No. Cancel. Escape. Okay. You undo first. Undo. Okay. Don't key in B. I just key in B. Okay, binary. Okay, click the binary. Okay, so 3, 4. Okay. So always it will show the next one, next variable. Okay, enter. Okay, this one you give it a name. Temporary. Sorry. Temperature. You just put T less than. No. Just put the symbol less than. Yes, 40.
40.
Sorry, 50. Okay. Alright. Why I cannot see the name? You symbol here. T less than 50. Okay. Oh, I think cannot symbol. I think. Okay, you just double click. Enter. Okay, you put T. Just put T underscore 50. So you know, so from here we know like it's less than 50. Okay. Do the same thing here. This one can delete. Put one output. Yes. This one is a B. Yes. 3, 5. Okay. Enter. This one is still T60. Now, so when I start the heater on, but before heater on, the temperature must be less than, right? from this less than, I already created a memory, right? Okay, so I use this memory as an interlock here. Let's put here, click here, put normally open. Okay, you use this T50. T50, yes. Okay. So means when I start, I make sure the temperature is below 50, then only the heater can on. Okay. Now, above 60, need to off the heater, right? So you add here in branch. Yes. Normally open. T60. Now you try. Now what is the temperature now? It's 100 degree, correct? Okay, the temperature we set. We need to play here the temperature value. Double click here. Go to decimal. Is this one, this number, right? Yeah. So we need to play here. Click here. Yes. You put below 8,000. Okay, now the temperature is 36. No need to close this. We just use this to play. Okay. Maybe you can do like this. You close this. Yes. Okay. Oh, I close that. All close. Yep. Okay, go online first. Now 89. So I don't want 89. You put below. Okay, now you start. Can you start? Because this is a simulation, right? Toggle. Can toggle, can you see? But you see here. Must be less than 51. Okay, you open the eye. Put 9,000 or 8,000. Okay, you see, when the value 30, the temperature value less than 50, right? This memory is supposed to on, right? This is the one later I use here, so can on. But now this one is not on. Correct? But this one is supposed to on. You know why? Because you created heater, right? When you create a new, in the main you need to add this, correct? That's the first thing. Okay, now can on. Okay, now the I you off. You off this one. Because it's a push button, right? Okay, so since you're using latch is still on, right? Okay. Now we increase the temperature. Go to input. Okay, you bring to the center. Okay, now you increase the temperature to, don't increase straight away to 10,000. Okay, 51, right? 51, this memory also is already off, right? But still the is latch still is on. Why? Because must go above 60. Okay, you increase 1,500 or 1,300 or something. 63. Now can you see heater off already. Why? Because here. Okay, so this is how we use actually. In actual thing, you already do the scaling in the SAP here. So after do the scaling, then we use this. Okay. Now reduce back to 8,000. Okay, it's supposed to on back, correct? But not on because I need to press start again. So if I want to do like automatic run, it means this signal here must be always on. See, I draw it. So can I erase?
Yeah.
So it's like this. Okay, you start. You dash the heater. Then stop. You unlatch the heater. Then you do two comparisons. One is the less than the temperature 50. Okay, you put the T50, right? You use this T50 as the interlock. Actually, this is how the normally they will use. That's why I teach you the compare, the max, the move first, then only I go into the analog. Because after the analog, after the scaling, this is where they use. Okay? Then more than the same temperature 60. So this one they name it as a 60. Here T60. So now when they start, they make sure this one is less than 50, this memory is on. So they start and match. Done. So then it will increase to 55. Right. If go to 55, this memory will be off. But the heater will be still on. First latch. More than 60, this memory will on and latch. So when it go back to reduce to 60, reduce to below 50, this memory on back. But I cannot on the heater. Why? Because the start button I need to press. So it means if here this area, let's say is always on, then it can repeat. No? So but this is a push button. Push button I cannot make it into a like always on. So in that case what I do, let us start. I use a B binary, bit what? Bit 3 0, okay, what number? Already 4, you already use 5, already use, okay, 6 for example. So this one I put like a run. Then I on the run start. So what happens when I press start, the run is on. So the run is will be like always on. I use this here. So when I press start, the run is on. So this guy will be always on. Now it's depend on these two only. latch and latch, latch and latch, latch and latch. This one.
Right.
So you add one more line below. Start, okay. You add one output. Use
Control.
no. Put that address first. B. Yes. 6, okay. For this, okay, run, okay. Now latch the run. No, that run is okay. Here. You add a branch. Okay. Yes. Okay, normally open. No, normally open. Yes. Okay. Run. Okay, let's stop button. Add a stop. Click here, click here, click here. Yes.
Try to
Okay, now try.
work.
Oh, you forget to change this. Go up, go up, go up. Go up. Ah, this one must be running. Okay. That one. No, you change the no, no. It's not okay. If you want to change address, you need to click on the address. Yes. Enter. No, no. Correct, correct. Run. Just enter. Okay. Send one. And I will run. Okay, go up. Start. No, no, start. Yes. Toggle on, toggle off. Yes. Okay. Now keep them on because what is the temperature now? Okay, 36. Okay, you on the input. You just play increase, decrease. Yes. latest HRDCorp is using Studio lah, Studio 5000.
Studio 500.
You know what version they're using?
I need to ask.
Yeah. Actually, I look like it's very straightforward to convert. But the thing is, it's lost the PLC to my output. That's the problem. It's not actually we just save as a ACD file. And this one, then just open it. But the thing is, you need to open that. That's the problem.
Oh,
You know, open?
cannot open. I tried before already.
No, of course not. Okay, now. Okay, I need to power up the laptop. Because in that case, I can do the thing part. But the PLC5 is software I need to check because you know I was all the time on the software. In the CD, I need to check the CD bottom up. You just give me, just copy me my file. But they said need to save as lah first, but I mean check can open. You go to open your SLC500. You open any files? Any file of yours? Okay, just go to file, save as. Okay, the save type you choose ACD. No, you save in my drive. Sugar AD. See, with this one, I can convert to here. This one. This one, HRDCorp. Okay, go to L73. Yeah, the revision for the revision 20. Next. Keep existing hyper public. This is the
I really copy these two. To
Yeah. Try for it.
Oh, you say just now I say what? Oh, what?
No, this one is
Oh, yeah, this is
TC,
you say carefully,
it must, the same method must have the one common right. Same method must have both the software. Because there's no install the PLC5 here or the SLC500 also same. And you install here. After convert, there's no launching, right? Need to click the launch. Then only I can close.
Okay. Inside, you got two this, you see this like, you can open, you can show the station, you see, redundant network. Many, okay. Open this.
A and B lah.
Yeah, redundant. Oh, I go 3.
From 10 to 29, so it's 90, 20. But all these are control net adapter.
Yeah.
Adapter, right? The details they just give you the part number because it's the control net part number, what is the revision they're using, everything. Yes, it's the only display. Just click here, it's just
Oh, they jump to that.
jump to the they show you the address lah. Mostly the main thing is the address there. Control net address, the revision. Average, transmit, range, schedule, transmit. Because the control net, yeah, for control net, they use the RS network software. clear limit make it 0 lah. First pass.
But this one
Not
is
equal.
just
NEQ, NEQ is all comparison. Compare, compare, compare. Move. What the value is. But the thing is, we need to know what is N for data. Then we need to trace. For configuration. Yes. This one is a boundary.
But this one is the SLC5 the machine file. Just now the PLC file is the control between the main PLC with this machine file.
Yeah. But this one don't have control, right? Mainly the data, right? What they call this? Take data, then send to the PLC file. Is it?
Yes. Right.
Go to configuration. No, you go see can one else control X can. Yeah, this is where it's problem. Put the PLCs and all this is output autonomy, right? Moving to PLC. So you take data from the control net, then here it will operate outputs. All is a linear output.
503 is the same this one?
Similar, but yours
Not
is
exactly the same.
OS 302. Mine is 300. So 302 have a 16K memory, the floating, everything they have. Mine is 300, no floating. It's a 8K memory.
Take one file to change the extension to .ss cannot
Can I also try this one?
Oh, not so straightforward
Yeah. Because it's just same as right, so I also thought, hey, maybe we can.
Boleh ya.
Yeah. You need to install both the PLC file and the RSLogix. What version you want to use? That particular version you need to install, then only can convert. Because I see the manual. Because they have a manual for this conversion manual. But actually I need to the file can convert directly, but the IPOs are need to convert one by one.
One by one.
Not like one by one, like data by data need to convert. Because counter is different.
The RSLink Classic Gateway need driver or any computer can download from online or need license also. RSLink Classic Gateway.
RSLink class actually, I think that one no need to license.
This is the driver, I mean this is the software required for computer to talk to the RSLogix, right?
Yes.
I mean to connect to this.
Yeah. The software that needed for communicate laptop to your PLC. For all the software, PLC5, SLC500 and then HRDCorp, all same. Even the micrologics, all that.
This emulator, how I can add more model? Emulator is not here. For example, now this classic gateway already. Yeah. So how to add a new
Good communication, configure driver, emulator, configure, station 3. My driver is
I want to add more. Yeah. This emulator is like. My question is like, only can add SLC500. I cannot add other model emulator.
No, because in your laptop you only install the emulator for SLC500. So, if you install emulator for 5,000, yes, then can have.
Oh. This one is for the SLC 5,000. I mean 5,000. This driver. For this this one?
Soft logic 5, right? This one, but I cannot get. Okay, add. Okay. But I don't have the PLC. Only that. Yeah, this one
It's not in the emulator. It's a separate.
yes, separate one because this one is for 500 emulator.
Oh.
This one is the AB. This one for the controllers.
Okay.
Because it's not going to remove because your simulation is still going.
But it's still SLC500.
Yeah, SLC500. The 5000 is this one. This one. Then you need to open the 5000 emulation. Then you can see here. But in the 5000 now you can add modules. But only can add input output. One input, one output.
Okay, now it's a lost connection already, right?
Yeah, because the emulation is off.
Oh,
If the emulation is on, then it's good. Okay. And tomorrow we'll do the control logics.
Okay.
So we can see the difference. The next training, before the next training, try to install one laptop, the PLC5 and the studio. Then I try to do that. Maybe the 30th training I can show you. Okay. No question. I think we can add a session.
Okay, see you tomorrow.
Yes.